Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Curious, quick fact to start. Last year's higher tier papers lost more marks on one histogram question than almost any other single question. Students read the bar height as frequency and wrote down the wrong numbers. 3 marks gone. If you've ever stared at a histogram and felt unsure what the bars mean, stick with me for the next 12 minutes. This one misconception is easier to fix than you think.
Right. What is a histogram teaching you in plain English? Think of each bar as a block whose area, not its height, counts how many observations fall into that class. If class widths are equal, height and area match. If widths differ, the height alone can mislead you. In exams, they expect you to treat area as frequency, so let's unpack how to do that step by step.
Start with 3 definitions you'll use every time. Class interval, the range of values in a bar, for example, 20 to 35. Class width, the difference between the top and bottom. Here that's 15. Frequency, how many items are in that class. Frequency density, frequency divided by class width. Frequency density is the height of the bar when widths differ, because area equals height times width, and area must equal frequency. So, the formula you must remember is simple. Frequency density equals frequency divided by class width. Write it down when you start a histogram question. Then draw or check the histogram so the bar heights match those densities. If you do that, the area of each bar, height times width, will equal the frequency shown in the table.
Why does area represent frequency? Think physically. A bar is a rectangle. The number of items in that class sits inside that rectangle. Taller or wider rectangles hold more items. If you halve the width but keep height the same, the area halves, and so should the frequency, unless you change the height. That's why unequal widths demand frequency density, not just height.
Now, the second thing you need to be confident with, estimating medians and quartiles from grouped data. You won't usually get an exact value, so examiners accept linear interpolation inside the class that contains the median or quartile. The formula I want you to write in your answer is value equals lower class boundary plus position minus cumulative frequency before class divided by frequency in class multiplied by class width. Show each part. Examiners like to see it. That brings us to what the examiner actually wants to see. First, a labelled table showing class intervals, widths, frequencies and frequency densities. Second, a clear cumulative frequency column if you're finding medians or quartiles. Third, the interpolation calculation with numbers substituted and the final answer with units. If I were marking, typical allocation is M1 for the setup, density table or cumulative column, M1 for the interpolation method, and A1 for the final answer. So even if your arithmetic slips, method marks can save you.
Common errors that lose marks: forgetting to divide frequency by width, failing to show cumulative frequency so the marker cannot see where the median class lies, and writing an answer without units or with insufficient working. If you show the table and the interpolation, the examiner can award those method marks even when the final arithmetic is messy.
Quick win checklist. One thing to do every time you meet a histogram question. 1. Convert frequencies to frequency density using frequency divided by class width. 2. Create a cumulative frequency column. 3. Find the position you need. For median, use half the total frequency. For Q1, use a quarter, Q3, 3/4. 4. Interpolate inside the class using the formula I just gave. 5. As a final sanity check, multiply the bar height by its width. That should return the original frequency. Do this every time and you'll stop losing basic marks. Time for a short worked example you can copy into your exercise book. Dataset. Classes 0 to 10, frequency 5, 10 to 20, frequency 15, 20 to 35, frequency 30, 35 to 50, frequency 10. Total frequency is 60. Pause the podcast now if you want to try it yourself. I'll walk you through it step by step.
Step 1. Compute class widths 10, 10, 15, 15. Step 2. Frequency densities 5 divided by 10 equals 0.5, 15 divided by 10 equals 1.5, 30 divided by 15 equals 2, 10 divided by 15 equals 0.667. If you drew the histogram, those heights would be the bar heights. Step 3. Cumulative frequency. After the first class, 5. After second, 20. After third, 50. After fourth, 60.
Find the median position. Half of 60 is 30, so the median is the 30th value. Which class contains the 30th? The cumulative frequency reaches 20 after the second class and 50 after the third, so the median class is 20 to 35. Apply the interpolation formula. Lower boundary L is 20. Cumulative before this class is 20. Frequency in the class F is 30. Width W is 15. Median equals 20 plus 30 minus 20 divided by 30 multiplied by 15 equals 20 plus 10 on 30 multiplied by 15 equals 20 plus 5 equals 25. So the median is 25.
For Q1 and Q3 quickly. Q1 position is 0.25 times 60 equals 15, which sits in the 10 to 20 class. Using L equals 10, cumulative before equals 5, F equals 15, W equals 10, gives Q1 equals 10 plus 15 minus 5 divided by 15 times 10 equals 16.67. Q3 position is 0.75 times 60 equals 45 in the 20 to 35 class, giving Q3 equals 20 plus 45 minus 20 divided by 30 times 15 equals 32.5. So IQR equals 32.5 minus 16.67 equals 15.83. Those are the numbers you would write down with the interpolation steps shown.
A few rapid checks to avoid losing easy marks. 1. Check area equals height times width gives the original frequency for at least one class. 2. Label your axes, frequency density on the vertical and the variable plus units on the horizontal. 3. Show cumulative frequency when you interpolate so the examiner can follow your work. These 3 checks catch most careless errors. Recap in one sentence. Treat histogram bars as rectangles where area equals frequency. Convert to frequency density for unequal widths, then use cumulative frequency and linear interpolation to estimate medians and quartiles. If you want a one-page practice sheet with this worked example and 2 exam-style questions to try, visit jcacademyonline.co.uk and download it now. That's your quick win for today. Share it with a friend who's revising.
You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.